So this video is going to be on using the analog sensors in the Arduino, and we're going to work with the two main analog sensors that we have in our kit, which are the photoresistor and the thermistor. So first of all, let's just look at the kind of the general idea behind the wiring. So here you see the diagram of the wiring. You notice that you've got some kind of voltage in. So in our case, we're just going to use the 5 volts from the Arduino. It goes through the sensor, and then we have another resistor that's wired to ground. And in the middle, we have a pin. We have a wire out, and that, in the case of using the Arduino, is going to go towards the Arduino analog sensor. So as we learned, we talked in class. When we have resistors wired in series, we get a voltage drop across each resistor, and so by the time the potential drop from the battery end to ground will be the full voltage. So we'll lose some across each load, across each resistor. We're going to use this in order to kind of figure out what the resistance is of a sensor. Now this is a sensor, right? This is a schematic for the photoresistor. So this is a resistor that changes resistance values based on the amount of light being input into it. So as we change the amount of light, the amount of resistance is going to change, and therefore the voltage going into the Arduino is going to change, and we're going to measure that. The key idea here is that we're using a voltage divider. Now, I've written down here the formula for the voltage divider. It's a application of Ohm's law, and I highly recommend that you try to go through and derive it yourself. But regardless, we can see that the ratio, there's a ratio here that determines what the voltage out is. Now that we've seen a picture of the circuit, let's go ahead and look and see what kind of voltage values we're getting out of this. So we're going to get out our trusty meter, and we'll see that, okay, so just kind of normal, normalish light, we have about 2.5 volts. Now remember, the max range we have is from 5 volts down to 0 volts. So let's look and see what happens when we cover this up. So we go down to about 1, and we would see that if I took the iPhone flashlight and put it right up to it, it went up to about 4.5 volts. So this is a good range. How did I get that range? Well, it's going to depend a lot on choosing this resistor. There are several considerations, but in this case I used a 10 kilo ohm resistor because it gave me a good bottom and top range. There's kind of an art to this, and there's some considerations that you need to take into account, but in this case 10 kilo ohms is good enough. Now so now that we've seen, now that we've seen how this line out from the V out works, let's now plug this into the Arduino, and that's going to be really straightforward. We're just going to stick it into the analog pin. So let's do that. At this point, we're ready to input the code that we need to get the Arduino to read the values from our voltage divider being controlled by our sensor into the computer. So again, as you see, I've got the code in a still frame here. I'm not giving you the file. I think it's very important that you copy this, with your own hands and by typing it in. So in this frame, we see a bit of a close-up of the Arduino code, and so let's just again go over it really quickly. We have the pin number that we're going to use. Again, it's generally a good idea to create a variable name for that. We're going to use a serial monitor to read our values for now. You'll see the comment there. This is not something you're probably going to want to have in there when you're making your final projects, but this allows us to see what's going on, since clearly we can't see the voltage changing just on our own. Once we get into the loop, we see that really the main kind of command that we're going to use to read our values, and that's this line that says int valRead equals analog read pin. This is going to take whatever voltage value coming into the Arduino from our voltage divider, and it's going to put it into a variable called valRead. That's a name that I just came up with. You could use anything you feel like at that point. Regardless, we're going to take that value and we're going to output it to the serial monitor. I put a little delay on it, just to kind of slow things down a little bit. You can play with that if you want. But this is the code to read an analog value. Now what you'll do shortly hereafter is to take those values and do something with it. Use if statements to turn on a motor or turn on a light or do whatever you need to do. So you'll notice in the serial monitor the values we're getting are not voltages, they're numbers, and in fact those integers, and those integers will range from 0 to 1023. To fully explain this will deviate a little too much from the purpose of this video, but if you remember when we looked at our voltage meter that we had about 2.5 volts for the sensor at ambient light. In fact, Arduino will split up the range from 5 volts to 0 volts into 1024 little steps, which is why we get 0 to 1023. So you could convert those to voltage values if you so chose. However, most of the time we don't have to do that. We can use the numbers as is to input into our if statements to make decisions. So that wraps it up. Remember, this was just a quick little tutorial to give you, kind of some extra advice on wiring up the analog sensors and getting them read in the Arduino. Again, from here, we're going to use those values to do something interesting. Have fun.